Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question which states that find the derivative of the following functions. So these are the functions. So solution. Now, if you analyze, now let's analyze these functions. You can obviously see that in these functions is different from the one. Especially these two functions. These two functions are different from the normal one we saw, whereby y, which is the dependent variable, is isolated to the left-hand side, and all the other variables of x are isolated to the right-hand side. X is the independent variable, and y is the dependent variable because it depends on the values of x to attain its own value. So, in this equation, towards the left-hand side, you can see x and y variable. You can also see x and y variable on the right-hand side. So, in this kind of equations, they are called implicit equations or implicit functions. They are called implicit functions. So, in this kind of functions or equations, we are going to differentiate them implicitly using implicit differentiation. In that case, we are going to isolate, after we differentiate them, we are going to put dy dx on the left hand side. So we'll correct dy dx, we'll move it to the left hand side and we make it the subject of the formula. So now let's do this. Number one. So now let's differentiate this. And in this one, if we differentiate y, we'll add dy over the x to it. So x cubed is what? Is 3x squared plus 3y squared, then you add dy over the x. Usually when we used to differentiate normal equations, that is y is equals to x squared, we used to say dy dx is equals to 2x. That dy dx is actually the derivative of 1y, because derivative, that is why we say dy dx is equals to, it's the derivative of y. Then it should be 1 dy over dx. So that's it. Derivative. So dy over dx stands for the derivative of y with respect to x. So this becomes, we're going to use product rule here. So it becomes, if you differentiate x first, you get 3y. Then if you differentiate y, you get what? 3x dy over the x. Another way you can also do it another way. You can put 3 and open brackets, then we have applied product rule to this. But you can also say 3 or open brackets, then you differentiate one of them. Maybe x, you put y, plus differentiate y, you put x dy. So anyway, but we have applied this. So if you apply product rule to this, you get this. Then we correct all terms that have dy over dx to the left hand side. So it will be what? 3y squared dy over dx minus 3x dy over dx is equals to 3y minus 3x squared. So now we factorize dy over dx. Dy over dx becomes what? 3y squared minus 3x is equals to 3y minus 3x squared. So now this becomes dy over dx is equals to 3y minus 3x squared over 3y squared minus 3x. So you can further simplify it. Y minus x squared over 3y squared minus x. 3 will cancel 3. So dy over the x, and y over the x is equals to y minus x squared over y square minus x. This is the final answer. So this is the final answer for the first one. Now let's move to the second one. So now let's find the derivative of the second one. In the same way, we'll find the derivative implicitly. So it will be, here this one will be 2x plus 2y dy over the x equals to 1 plus dy over the x plus 0. So now we'll correct these terms to the left hand side. So it becomes 2y dy over the x minus dy over the x is equals to 1 minus 2x. So this becomes what? Dy over the x, 2y minus 1 is equals to 1 minus 2x. So now our dy over the x will become 1 minus 2x divided by this 2y minus 1. So this is the final answer for the second one. So here's the third one. So this kind of differentiation, we cannot differentiate it without introducing the natural logarithm. Because if it were 3 raised to the power of x, it's easy. That one is 3 is 3x, is 3 raised to the power of x in 3. But this one is sine x. So we have to work this one before we can differentiate it. So we'll introduce the natural logarithm, which is ln, then to be ln y is equals to ln 3 sine x. This one, since it's a logarithm, we can bring the power down. So it will be ln y is equals to sine x ln 3. Now we can differentiate this. But now it will be an implicit differentiation because it's not y is directly is not the subject of the formula. There is a function attached to y, ln y. So we will differentiate this implicitly and make the y and over the x the subject of the formula. So now the derivative of ln y is what? It's 1 over y. Then you add dy over the x. Then this, ln 3 is a constant. So the derivative of sine x is what? Is cos x times the constant. So now we can remove 1 over y from here to make dy over the x the subject of the formula. So this will become dy over the x is equals to, this will go here, cross multiply, y will enter here, y will multiply by here by this cos to become what? Y cos x ln 3. So now, there is y, here is a y function, here is x function. All here has to be x function because the derivative of y with respect to x. So now, we'll substitute y. Y is 3 raised to the power of sine x. So here will be 3 raised to the power of sine x cos x ln 3. So this is the final answer of the third part. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.